Hello everyone, this video is about SOHCAHTOA. If we have a right angled triangle like this, we can label the longest side the hypothesis, which is across the right angle, and if this angle is theta, the angle across theta, opposite theta, is called the opposite side, and this angle which is next to theta is called the adjacent side. So this is always the hypotenuse across the right angle. The other one also near theta is called the adjacent angle. SOH is short for sine opposite hypotenuse, opposite over hypotenuse, cos adjacent over hypotenuse, tan for tangent, opposite over adjacent. So SOHCAHTOA. If we have this 3-4 triangle, of course, using Pythagoras, we can get the hypotenuse, which is 5. And you can use Pythagorean theorem to find the 5 here, because we are looking for the hypotenuse. If we are looking for the hypotenuse, of course, we add something squared, and we are adding 3 and 4 here, so 3 squared plus 4 squared. And yeah, okay, let's write it down. 3 squared plus 4 squared. That's how we get 5. The sine ratio is therefore opposite, which is 4. 4 is opposite the angle theta, so that's the opposite, divided by the hypotenuse, which is 5. The cos is, the adjacent is 3, obviously not drawn to scale, and the tangent is opposite over hypotenuse. Opposite over adjacent, so the adjacent is 3. And for sine, first of all, we can find the missing side here. This is the square root of. So if we are using Pythagoras, it's always square root of something squared, something squared. In this case, we subtract because we are not looking for the longest side, which is the hypotenuse. So we are looking for the one of the legs, and therefore we subtract, we don't add. We only add if we are looking for the hypotenuse. So what do we subtract? Well, we have only one option, 13 squared minus 5 squared. Otherwise, we will get an error if you use your calculator. So the sine ratio is, this is theta this time. So this time the opposite side is this, which is, by the way, 12 here if you use your calculator. The opposite side is 12, the hypotenuse 13, kah adjacent over hypotenuse, toa opposite over adjacent. For this triangle, this time we are also looking for the hypotenuse here because it's across the right angle. And if we are looking for the hypotenuse, of course, we add. And if we add, it doesn't matter, 8 squared plus 15 squared, 15 squared plus 8 squared, same thing. And for the sine ratio, SOH opposite, the opposite angle across theta is, the opposite side across theta is 15. The hypotenuse is 17, so 15 over 17. And the cos ratio, adjacent over hypotenuse, the tangent is opposite over adjacent. So if you're looking for this area, we only know the hypotenuse and the angle. We can first use sine and cos to find the base and the height of this triangle. So if we use sine 30 degrees equals opposite, which is the side BC, over hypotenuse, which is the tan. And now if we just multiply both sides by 10, we get tan sine cos 30 degrees equals, on the right, if you multiply by 10, we get simply BC, and therefore if you use your calculator here, you will get 5. So we have the BC, which is the height of the triangle. We can do the same thing for AB using cos 30 degrees equals adjacent over hypotenuse. The adjacent side is AB, the hypotenuse is 10. We multiply both sides by 10 again, we get cos 30 degrees equals AB only on the right, and if we use a calculator, we'll get 5 root 3. Now that we have the base and the height of the triangle, we can find the area, which is base times height over 2, and the base is 5 root 3. The height is 5 divided by 2. So for the final answer, we can say it's 25 root 3 over 2 if you use a calculator. Here we have an isosceles triangle. Let's start by labeling the vertices, say A, B, C. And as you can see, we don't have right-angled triangles. So we have to be creative and just draw like an additional line to help us here. So this line is the altitude line, which is perpendicular to the base, and let's call the foot of the perpendicular D. Right now, if we just focus on one of the right angled triangles, for example the ADC, right angle, the hypotenuse is 10. Now look at the angle here. There's no degree symbol, so this is of course in radians. So if this whole angle is 2 radians, a half of it would be 1 radian. So this angle is 1 radian. Now using sine 1 radian, so we have to use radian settings in the calculator. Sine 1 radian equals opposite, which is the AD side, divided by hypotenuse, which is 10. Multiply both sides by 10, we get 10 sine 1 equals AD. And yeah, we can use a calculator or we can just leave it like this. And for the CD, or the height of this triangle, we can use cos 1 radian equals the adjacent side, which is CD, divided by a hypotenuse, which is 10, multiplied by 10, we get 10 cos 1 equals CD. Therefore the area is, so if you're looking for the area of this triangle, we use the base, which is AD times CD, so it's AD times CD divided by 2. But remember, we're not looking for the area of the left half only. We are looking for the area of the whole isosceles big triangle here, so we're gonna have to multiply the whole thing by 2 again, which means you don't have to multiply by 2 twice. You just have to do AD times CD, and the AD is 10 sine 1 radian. The CD is 10 cos 1 radian. And if you use your calculator, remember to use radians. So in the mode, you have to press shift first actually. So shift mode, radian 4, so use radians, and we do 10 sine 1 times 10 cos 1, and we get 45.5 in 3SF. Alright, that's it. I'll see you again next time.